So now let's focus on convection as it happens within the mantle. So just a quick review and to help you understand, everybody's seen something like this in their lives. This is a lava lamp, and as you may know, they get very hot. And the heat source is down here toward the bottom. And in here, there's like a fluid, maybe water, maybe something like that. And then there's big gobs of sort of wax. And the lava lamp works by, it heats up down here and the wax goes up and then they fall down. And it sort of happens like a cycle. And convection happens the same way. There's some type of heat source. It gets warm. The waxy compound start to get less dense than what's in the water. And then they come up here, they cool down, they get more dense, and they start to fall. So what we have to understand when a convection current occurs, it works basically because of three things. Some type of heat source, gravity, and density. Those three things help a convection current to occur. So in the mantle, which is still under amazing amount of pressure. And if you go to this one, everybody has problems on this problem here when the mantle works the same way. The heat source is the core. It's extremely hot, like surface of the sun hot, okay? And what that does is heats up the mantle. The mantle is not completely solid. I mean, it's under a lot of pressure, but it's not completely solid. I would make a comparison to like, the asphalt that you see being laid down onto roads, like that type of plastic movement, okay? And as the heat from the core heats the mantle up, these particles move faster and the density decreases, causing it to rise. Now, as it moves further up in that mantle area, it encounters the crust, which then causes it to cool because it's further away from the core. As it cools, the particles move slower, they occupy less space, and the density increases, meaning it gets heavier. Then it begins to sink back down. So the mantle rock will then fall, and that cycle occurs again. Now, in the video you may have watched that shows this convection current occurring inside the mantle, it moved very quickly. This process can take up to 50 to 200 million years. So it's basically the same rate at which your tectonic plates move, which is basically as fast as your fingernails grow within a year. So that's pretty slow, okay? And that's why we don't have earthquakes and volcanoes occurring constantly and the plates moving very quickly. They move very slow based on how the convection currents move in the earth. So if you take a look at this picture, a lot of people have problems here with this picture. You can see that this convection current happens in the same way. And the core is heating up the surface or the mantle material, causing it to become less dense. It rises because it gets replaced by, denser material down here. It gets pushed upward. It cools along here, and then when it encounters this crust material, it sinks back down because it becomes denser. Gravity pulls on it, and then you have it going through this same cycle once again. So you can see that these convection currents are occurring at different parts of the world. Some occur deep within the ocean. Some do occur on land, like in Iceland. And you can see, again, the core and gravity and density are the reasons why this happens.